Hello everyone, welcome to this section on K-means clustering algorithm. In this section, we will learn about K-means clustering algorithm. It is an unsupervised learning technique. So far, whatever algorithm we have discussed are primarily supervised. That means they deal with label data. But in absence of any label data, how you can use some techniques of machine learning, we will showcase it here. So K-means algorithm is one of the different unsupervised methods that are available to deal with unlabeled data. We'll primarily start with a brief introduction about K-means clustering. Then we'll move on discussing different concepts around K-means clustering algorithm, and we'll try to answer one of the very important questions about this algorithm, that is how to decide the optimal value of K. Then our main focus will be on how we can use K-means clustering algorithm to solve certain business problems. We will also talk about different pros and cons of K-means clustering algorithm and then gradually move to the case study. A quick introduction to K-means clustering algorithm. As you are already aware of the fact that K-means clustering is one of the unsupervised machine learning algorithms. The goal of such algorithm or learning is to find the hidden patterns or structures of the data in which no target variable exists to perform either classification or regression techniques. Unsupervised learning methods are quite challenging, as the outcomes are subjective and there is no simple goal for the analysis, such as predicting the class or continuous variable. These methods are performed as part of exploratory data analysis as well. On top of that, it can be hard to assess the results obtained from unsupervised learning methods, since there is no universally accepted metrics for performing the validation of the results. Clustering is the task of grouping or combining observations in such a way that members of the same cluster are more similar to each other and members of different clusters are very different from each other. So clustering is commonly used to explore a data to either identify the underlying patterns in it or to create a group of characteristics. Unsupervised learning sometimes works as an intermediate step in case of any supervised learning as well. Let's deep dive a bit more and explore how does K-means algorithm work. The K-means clustering algorithm is an iterative process of moving the centers of clusters or centroids to the mean position of their constituent points and reassigning instances to their closest clusters iteratively until there is no significant change in the number of cluster centers possible or number of iterations reached. The cost function of K-means is determined by Euclidean distance, a square norm, between the observations belonging to that cluster with its respective centroid value. So it starts with generating K centroids. The value of K is predetermined when you are working on the K-means clustering algorithm, and we'll share more detail about how we can find the optimal value for the K as well. It starts forming cluster based on the points closest to those chosen centroids. Centroid distance calculations are performed by taking the Euclidean distances. In the next iteration, a new centroids are calculated from the assigned instances for that cluster or centroid. New centroids are calculated based on the simple average of the assigned points. In the next step, new assignments are calculated again based on the Euclidean distance between instances and the new centroids. In the event of any changes, new centroids will be calculated iteratively until no changes in assignments are possible or the number of iterations has reached one of those stopping criteria. Like cluster reassignment results in the same cluster, so you're not able to arrive at any different clusters from your previous iterations. A specified number of iterations which you have already given is reached. So reassigned centroids are located very closely to the previous centroids, so there is no possible change in the formed clusters. This section illustrates the approach followed in case of K-means clustering to form the groups. For example, training examples are marked as dots and the subsequent images shows the formation of clusters starting from identifying random centroids till the point where no assignment of observations is possible in the formed cluster. The method stops at this phase and final clusters are formed.